In this video, I'll show you how to integrate trigonometric functions containing sine and cosine with odd powers. This is part 1. To tackle these types of problems, you'll need to follow these suggestions, and we'll refer back to them as we complete each question. Starting with question 1, we have the function cosine x times sine to the power of 8x dx, and they want us to integrate that. Now, the reason why I consider this question to be easy is because you don't need to integrate by parts to find the answer for this. All you need to know how to do is use substitution. So if I choose u as my sine x, and I find the derivative of both sides, I get du is equal to cosine x dx. And if I solve for dx here, I end up with du over cosine x is equal to dx. I'm going to substitute this back into my equation, where I have the integral of cosine x times u to the power of 8 du over cosine x. So I replace this dx with du over cosine x. This cancels out, and we're left with the integral of u to the power of 8 du. The integral of u to the power of 8 is equal to u to the power of 9 over 9 plus c. Substituting sine x back into u, I end up with sine to the power of 9x over 9 plus c. And that is the answer to our first question. Now, of course, they're not all this easy. They actually get very complicated. And in question number 2, we're asked to find the integral of cosine to the power of 3x times sine to the power of 8x dx. With these types of questions, u substitution also works, but you have to keep in mind these suggestions. And one of the suggestions up here says that if one power is odd, split up the odd power. So cosine to the power of 3x is the odd trigonometric function. I'm going to break cosine 3x into cosine times cosine squared x. So here's our new function, cosine x times cosine squared x times sine to the power of 8x dx. One thing that may not appear to you right away is that this cosine squared x can be replaced with 1 minus sine squared x. Remember this identity? Cosine squared x plus sine squared x is equal to 1. Well, if I move this over, I end up with cosine squared x is equal to 1 minus sine squared x. And this is equivalent to that expression. So I'm going to replace this with that. And by doing that, it actually makes the integration a lot easier. So 1 minus sine squared x. And of course, there's no instructional manual to this. I happen to see it. And if you happen to see it, it's even better for you. Times sine to the power of 8x dx. I'm going to use substitute now and choose my sine as my u. The reason why I chose sine as my u is because A, there are two sines here, and B, the sines have an even power. So you want to look for that. Taking the derivative, we end up with du is equal to cosine x dx. The derivative of sine x is cosine x. Solving for dx, I get dx is equal to du over cosine x. My new function looks like this now. The integral of cosine x 1 minus u to the power of 2, u to the power of 8. And I will also replace this dx with what I found, du over cosine x. These will cancel out. I'm going to multiply this u to the power of 8 inwards, and I end up with the integral of u to the power of 8 minus u to the power of 10 du. Taking the integral of these two terms is really easy. U to the power of 8 becomes u to the power of 9 over 9. This becomes u to the power of 11 over 11 plus c. Replacing u with sine x, I get the final answer of sine x to the power of 9x over 9 minus sine to the power of 11x over 11 plus c. And there you have it. That is how to integrate trigonometric functions containing sine and cosine with odd powers. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, visit our website at studyforce.com. We're an online service for students seeking free homework help. See you soon.